Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video we are going to work on the two-port network for BJT and FET device effects of RL and RC under load condition. So the last video we did it under no load. In this video we are doing it under load condition. So of course we are using the same example, which is previous example. So same thing. What's the difference here? This is the only difference. Look at it. Sorry. No load. Loaded. Okay, this one has load. That's just the difference. So all our values were calculated for RE, IE, IB the same. We are using the same example. Okay. So under load condition, our input current equals input voltage over input impedance. Okay. Similarly, output current over equals minus output voltage over, what is the resistance here? Is the load resistance. Why do we have a minus sign here? Now it's because we judge our current to come in this direction. Okay, so that's one reason why we have it as a minus sign, and that will help us land in same answer. If we judge our current to go in this direction, we are going to have a plus sign here, and that will affect some other things around here. So just to keep things balanced, as we judge our current to be moving in this direction, we have a minus sign there, opposite direction. Okay, now with this being said, this is the last part right here. So current gain will be what? Output current over input current, and we just said that this is what? Input current. Okay, so it is output current. So in place of output current we have everything here, divided by, in place of input current we have everything here. Okay, everything here. So when you simplify that, you end at having this. And of course, let's take it closer. When you simplify it, look at it, this, look at it here. When here becomes multiplication, this guy will swap now. Swap. Looking at this guy, you can just write V out over V in now. You can do that, V out over V in multiplied by this over this. And V out over V in is what? Voltage gain. Okay, voltage gain. So current gain equals negative voltage gain, input impedance all over the load resistance. If we work an example with it, okay, let's see if we can work an example with it as fast as we can. Okay, good. I like the fact that I brought this diagram here this time to help us. Now this circuit is similar to the previous one. The difference is that here has a load. What is that first example? Yeah, same thing but no load. Now this example, what's up? So this example, same thing but there is load, better load. Okay, so solution. So from previous example, all those calculations for IE, IB, RE is the same thing, so I'm not going to repeat it in this video. It's the same thing. So it's from previous example. The difference is that we are having load. Okay, so the A part now, where we are calculating for calculating for voltage gain. So we do this. Okay, this time our voltage gain, since we now have load resistance, we have to take that into account. Okay, we've already calculated for voltage gain at no load, right? So at no load, this is it. But now that we have load, we have to consider the load resistance divided by the load resistance plus this resistance of 470, which is the base resistance. Why are we doing this? This calculation is based on the principle of voltage divider rule. Okay, what is that diagram? Yeah, based on voltage divider rule. So voltage gain based on voltage divider rule, and on voltage divider rule, let me write it somewhere. Okay, voltage divider rule, it's written mathematically like this: Vn equals Rn Vs over Rs. Okay, this is the place, the number, the position you are looking for. This is the resistance at that position. This is the sum total voltage. This is the sum total total resistance. So with that idea, we are saying that since we are looking for the voltage gain, okay, that resistance in that position, we take that resistance, which is this, all over the sum total resistance. Okay, so that's how we have this right here. Okay, I think we've also done something like this in previous videos. So you do this, you compute this, and you get this value as your answer. Then output current gain. We solved this in, I think, the previous slide just now, how to get this. So all we have to do, we just substitute in the values. This guy will bring this here, and then we'll plug in these values, and you have your current gain. Okay, so substituting the RE model will result in the figure below. Note that the question says we should determine the voltage and current gain using the two-port system approach, which we have just done, okay, in the A part. But B part, we want to do it using we want to determine the voltage and current using the RE model, and of course this is the RE model. Okay, so in this RE model, now look at this, these parts, they are parallel. Okay, so this is the load, let me say this is a equivalent load resistance. Okay, all the resistance at the load side, and that's what ROC parallel to RL, ROC parallel to RL. Okay, and of course you just put in the values. ROC puts its value, ROC, RL put the value. Okay, and you get that. Then for V out, output voltage is what? Beta IB. Where is our beta IB? Yeah, look at it, beta IB. Voltage, of course, is current times what? Resistance. So the output current is what? Beta IB. The output resistance, as a load resistance, is what? This guy, which is this. Okay, so what they did at first is to calculate IB, where IB equals what? Input voltage all over beta RE. Okay, input, look at it right here, IB. So VI, input voltage, current is the same as what? Voltage over resistance. So the input voltage over the input resistance, this is the sum total input resistance. Let me just say it that way. Okay, so that will give us this value. So what they did now is to say this thing where you have IB, carry everything, plug it there, which is this. Okay, and yeah, so this is output voltage. So for the voltage gain, you will now bring all this value, output voltage, you put it here, divided by what? Input voltage. This will cancel out this. Okay, this cancel out this, and then what happens next? You now say what we left is what? Oh, of course this will cancel this. So what I have left is what? Minus R prime L, or RL prime all over RE. Okay, and then we've calculated this value already, which is this. We've calculated it right here. So you just substitute that in, you have this value here divided by RE. We've calculated it already in the previous slide. I said we are using the same example, so the values are the same. So this divider gave you this value. Same with the other pattern. Same with the two-port network pattern. Same value, I mean. Then the current gain, this over this. Now we have already done the analysis of this guy, how we got this using current divider rule. Okay, so IB, which is the input at the input side, okay, the total current multiplied by the resistance at that point, where are we? Total current II multiplied by the resistance at that point, ROB, okay, divided by the sum total resistance, ROB plus beta ROE, and just plug in the values, you get this. Of course, this is 0.9977, which is approximately 1. Okay, so approximately 1 I is the same thing as I. Then for the output voltage, we did the same analysis with it. Okay, here out the resistance at that point multiplied by the total current coming out divided by their sum, that will give you this. Of course, we've said IB equals what? Approximately equal to I, so we have I in this place, and when you do that, you have what? 57.69 I. Okay, then current gain, I out over I in. When you bring in this value, I will cancel I, equals 57.69. That's your current gain. Whew, guys, I know this is much, but to understand this last video, this particular one, to understand this one, to understand the video before this one, please check out the previous one. Okay, check out the previous one. In fact, if you want to watch the video in this playlist, start from 1, 2, 3, 4, because they build on each other, and we can't really on this video we can't really go back and explain what we've explained in a video before. Okay, so please just do that, help yourself out, and then comment, like, share, subscribe, click on the notification bell, and thanks a lot for watching, and bye for now.